these are all the items that were sent in to us by a gentleman called Everett. Everett's got a YouTube channel. It wouldn't do any harm to go and have a look. There's some World War spanners here. This one is particularly intriguing. It's obviously been homemade or home bent, and it's been well used, so I can tell a few stories. There's various drills and transfer punches that were surplus to a job, and of course there's a fly cutter, which is going to be this week's giveaway. Pocket reference book, I've had a flick through that. There's lots of interesting information in there. Taper shank drill. All these drills are cobalt. They're Chinese cobalt, but I found Chinese cobalt to be alright. Anyway, Everett, thanks very much. It is much appreciated. A lot of these will be kept and used, some will be given away. Anyway, thanks once again. This is another oiler of a steam traction engine. This is the real I-arm. This will be 100-year-old. The original oiler. The problem it's got has some damage in there. The threads are damaged, quite badly damaged. The top, if you're looking to screw on straight, and the oil is actually leaking out of that damage point there. I've thought about various ways of repairing this, but honestly the best way would be to cut that off and remachine the threads further down. It'll hold slightly less oil, but I'm sure it'll still do the job. You can see how the work inside has some cotton waste and a little bit of wire. The oil gets soaked up by the cotton waste, and it slowly goes down the wire by capillary action down that tube, and that's what feeds the bearing. I think this is off a big end bearing, I'm not quite sure. The other thing is that's brass and the top's bronze, which again tells me this isn't the original top for it. It just doesn't want to screw on any further than that. It just goes cross-threaded straight away. I measured the thread's 18 TPI, which I can cut no problem. So I'll set this up in the 4-jaw chuck, run as true as possible, cut that off and remachine some threads on. If I knack it, I'll just have to make another one, that's all. But I think it'll be alright. I think I'll be able to get away with it. See the damage on there. The threads are really well mangled there. The top's not straight. I don't know what's happened there. See the tube inside that the copper wire goes into, and that the oil goes down there into the bearing. Right, I've got it tucked into the 4-jaw chuck. I've got it within sort of 15 thou. The trouble is it's not round, it's not giving it a true reading. I'll just have to go with what I've got really. It's like a compromise between having it, well, it's what it is, that's exactly what it is. Right, so I'm going to cut the end off and rethread it. That's the only way I can repair it. If I make a balls of it, I'll just make a new one, simple as that. I quite like this sort of work, restoring work things like this. I'm getting a little bit more work now, which is good. It's something you're doing something that has a fair chance of surviving. This isn't a throwaway item in a throwaway world we have today. This is the real I-arm. The only worry is how that's fastened onto there. I hope it's silver soldering on. I'll be really careful, nice light cuts. See what happens. Right, I can guarantee if I put a parting blade in there, this will dig in and tear out of the chuck. So what I'm going to use instead is a cutting disc and an angle grinder. If you can think of a better way of doing it, tell us. Right, I'm going to fix it now. nice thick wall, and I should be able to get some threads in there without too much problem, I hope. Right. I had intended putting some threads on the outside for the cap to screw onto, but I've changed my mind, and what I'm going to do, I'm going to bore the centre just so it's round, and I'm going to make a piece that'll slip in there with the threads on, which will keep it the same length, because if I do damage this, it's going to be a bit of a task to remake it, where if I just make a bush to go in it with some threads on, it shouldn't be too bad at all. I just want to get this as round as possible, and I'm just going to solder the piece into here once I get it made. Just about there. Right, and that's a nice rough finish, so it'll solder that quite nicely. I'm going to leave this in the chuck, just take the chuck off and mount with that chuck in the machine, the sleeve piece for that. A brass bar here, we'll get the bit we need out of there, no problem at all. I'm going to put a centre in it tonight as well. It is sticking quite a long way out of the chuck. Trusty Banggood centre, might as well use it. Right, so that's down to the size for the threads. I need to put a groove in here for the screw to drop into. I'm going to cut a decent depth of thread and then machine this end off, and that will be the end that fits inside the lubricator. Nothing but brass on the gears in here. Everything's covered in gold dust. I wish it was gold dust. Right. Right, I've measured that thread again and it's definitely 18 TPI. And this is a 19 TPI insert, so it's going to be very near. Right, so it's on centre height, it's square to the job. Time to cut some threads. Right, the gearbox is all set up. Once I engage this lead screw, I've got to leave it engaged and just reverse the lathe. Otherwise we'll have all kinds of problems. And zero the cross slide, a little bit of cut. Right, here we go. Right, I'm just going to check the pitch of the thread, absolutely spot on, 18. We're getting near the full depth now, but we're just about there. Let's cut and we'll give it a try so the cap actually screws on. Just to set it into zero before I lost my concentration. Right. Right, one more cut, one more spring cut on the same setting and that would be absolutely perfect. Right, now it's just taking it, literally fanning his hair off it. Disengaging because I know for a fact that's going to be good. Right, that's absolutely the donkey's knob, so to speak. Then in theory that should drop in just nice. Right. That just removed a lot of metal very quickly. I've still got to do a review on this ER32 collet chuck, but as you can see it's working very nicely indeed. It's doing exactly what it's supposed to do. And nice to get this lathe cleaned up. Hopefully we should start on here, no problem. We may have to clean the threads up with a file just on the very end, and a little rag on there. Just a job. Right, that's the fit I've achieved in there. It's a little bit slacker than I would have liked, but the solder, I'll take that up. I'll tin this outside, tin in there, that means give it a coat of solder, put them together, and it should be no problem. I've left it in the chuck in case I'm going to put it in the lathe to polish it up, and also the chuck will act as a heat sink in case this is just soft solder into there. So we'll get some flames and some flux and get it soldered. That's starting to run now. Okay, the solder's all the way around it. Okay, so that's all nicely clean with the flux now. I'll put it on my rotating table. Right, so that's nicely soldered onto there, soldered all the way through. Simply got a gold hole, back in the lathe now, and get it polished up. Whatever you do, Jim, you tempted to put your finger up the inside of there, because if it gets stuck, it'll just pull it straight off. Right, I'm very happy with that. That is a nice repair. Right, that's a finished article. Very nice indeed. I'm really happy with that. You can't even tell it's been repaired from the outside. Hopefully that will last another number of years. Once again, it's just time to say thanks for watching, thanks for subscribing, and as usual, a massive thanks for all the well wishes that have been coming in. I'd also like to take this opportunity to wish everybody a happy, peaceful and prosperous new year. I really mean that. I hope next year is what you want it to be. Anyway, thanks for watching. Ah, you bastard, you! Oh, John, give me a quick yourself, that's enough here, let's get this done.